Good morning, everyone. We're going to talk about the empirical rules in statistics. But first, we'll go review we talk about variability next week, and with variability. Anyone still remember the formula?
Not formula, but the concept.
Okay. Okay. Please tell me the concept.
Even if the average value is the same, but the statistics who values the most is not very good. It's not very good stock to investor.
Yeah, good. So we use variance as a measurement of the variability, and we calculate as sigma, sum all the deviation from the mean together and square it, divided by the total sample size. This is just for the population, but for the mean we will use, for the sample size we'll use 1 minus 1 as the denominator. Now we'll come to the second part is this was empirical rules today. These empirical rules is actually a good estimate of the spread of the data. And it can only be applied in this situation when the distribution of the data is bell-shaped. It's easy to understand. Bell-shaped. It's bell-shaped. It's mound-shaped. We know mound-shape. By definition, we call mound-shape. We see that the largest proportion of the data is centered around the mean. Suppose this is a mean. This is the mean value of this set of data. The mound shape can be like this. It's around this one. And also a mound shape can be like this. But it can also like this one. This is the mean. It's centered at the mean.
Yeah.
And also this one is not symmetrical, so a bell shape. You see a bell shape. We mean that it's a mound shape and also it's symmetrical. The distance from both sides distribution is the same. Okay. Shall I erase this? And so the empirical rules can only apply under these circumstances. This is a relative frequency. This is the value of the data. It can be used in continuous values. This is a mean. Now it's a bell-shaped. Doesn't look like that symmetrical. So what basically the empirical rule says that we will have 68% of our observations will fall into plus or minus will fall into this range. This is range to the mean plus or minus 1 standard deviation. So I'll show you that. This is 1 standard deviation. And since this is symmetrical, so we have 30% on this side and 34% on this side. And total is 68. So suppose I give you a whole set of data, maybe 1,000, and I tell you that they follow this distribution, the bell-shaped distribution. So you can guess that most of the data will distribute around the mean, 68%. And this is the first rule, and second is 95% of the measures will distribute it around 2 standard deviation. So this is 2 standard deviation. So we simply calculate for each side will be 95. And we know this is 34, so just this one is. But from here to here, the area under this curve is 47.5 on this half, and the total area from here to here is 95%. And the third This third rule says 99.7% of the observations we observe will fall into the mean. 3 standard deviation from the mean. Here, 3 standard deviation. So, what left out is 2.5 here and 2.5. So this involves a new term which called a rare event. Rare event means says it's probable that this will happen. It has a possibility that this situation will occur, but it's not probable. It's possible, but not probable. So we usually say that if some values falls beyond the 3 standard deviation, we say this is a rare event. Means it's possible, it can happen, but you are not likely to observe it. Not observe it. Okay, up to now I'm going to erase this one because we know that. I'll give you an example. Suppose you buy a battery, and in the advertisement, the manufacturer said, well, our battery, the average lifespan of our battery is 60 months. And the standard deviation, according to their previous experience, is 10 months. And the warranty is 30 months, which means any battery that can last below this month, they will refill a new one. Okay. So what we can draw, according to this information, and we draw, and they also told you that their batteries follows the normal distribution. So what it says, the center is 60, right? It's 1 standard deviation. This is 1 standard deviation. So this value would be 50. This value here would be 40, and this value here would be 30. Up to now, anyone have any question about this? So, similarly, this one is 70. So, so we are going to analyze this number. 30 is here. How would you like to buy a battery that can last less than 30 months? It's just the errors here, right? So the chance is only 2.5%. Okay.
I'm afraid it's not 2.5, it's 0.50.
What?
0.50, not 2.5, I'm afraid. 0.50, I think. Oh, 15.
Both sides?
No, one side.
Oh, I'm sorry. I'm sorry.
No, 0.50.
No, this one.
Yeah.
Oh, this is a huge mistake.
15. Oh, sorry.
15, right?
Yeah.
Sorry. So you can buy any. So this is really a very low bound.
Yeah.
Right. Anyone question? Okay, but
So we shouldn't buy the battery, right?
No. We can buy the battery, but what we know that is the most of batteries. This guarantee actually means nothing, right? If anything really happened, it's a rare event. It's really bad luck.
You mean that everything is
Yes,
possible?
if the warranty rate is to say 40, it's probably you can observe it. It's more likely to happen.
Yeah.
Oh,
So it doesn't mean so usually we say that the warranty, we can say that we are on 99. Say this is so the area from here, the whole area up to here is 1 minus. Do the calculation for me. How much the answer?
99 and point
99.
99.85%.
85. Okay. So the manufacturer will say like this: we are 99.85% confident that our battery can last for 30 months.
Yes.
Do you still have another question?
Thank you.